Welcome back to PC Builder, I'm Jason. Especially with higher RAM and SSD prices, we get tons and tons of questions from confused PC builders all the time. How much VRAM do you really need for 1440p gaming in 2026? How do you avoid a CPU bottleneck with your GPU? Does faster RAM really matter for gaming performance? How much RAM do you need for gaming in 2026? So I've gone through all of our recent videos and Q&As and put all that relevant info into one video right here. If you get value out of this video, please give it a like as it really helps out the channel, and subscribe for more cool PC content. Let's jump into it. This video is sponsored by VIP SCD Key. Say goodbye to crazy expensive Windows licenses and that terrible Activate Windows watermark. Right now, use the links in the video description, head over to VIP SCD Key and get a Windows 11 OEM license for a great price. Pick your product license, then use the PC Builder discount code PC25 for an additional 30% off. Go to the activation settings on your PC, put in the code, and boom! Windows is fully licensed for a crazy low price. And they have Microsoft Office licenses too. Use the links in the video description. Real Nizal asks, already some games like Indiana Jones may demand more than 12 gigs of VRAM for 1440p 60 FPS, especially with advanced features like path tracing enabled. Is it time to update my recommendations for 1440p gaming to 16 gigabytes of VRAM, similarly how I recommended 12 gigs for 1080p? Well, I've kind of modified, just FYI, the 1080p, because there hadn't been any 10 gig GPUs for a while, so I was saying 12, because really it was the 3080, and then everybody was just jumping to 12. But with the Arc B570, I do believe that is enough for 1080p gaming in most settings. That being said, you do start to run out of VRAM even in a handful of titles at 10 gigs at 1080p. But let's talk about 1440p, because that's really the thing. Is a card like this, I keep pulling the 5070 off the table here. This is an RTX 5070, but is this enough VRAM for 1440p going forward? I think if you're talking about games like Indiana Jones, which let's just say that's a special type of game where if you turn on ray tracing, this basically does not have enough VRAM at high settings to run that at 1440p. Even with upscaling, it basically runs out of VRAM. Hardware Unboxed has done a bunch of TechSpot, that's AKA Hardware Unboxed has done a bunch on that. But basically this GPU just stops working, right? The issue is mostly related to VRAM, of course. So if you look at 16 gigabyte VRAM GPUs that are slower, like the 5060 Ti, 16 gigabyte, another NVIDIA GPU, it performs better. And you're like, how is that possible? Well, it's because we're running into the VRAM limitations of 12 gigs. Right now, the limiting factor for a lot of games probably still is the consoles. That's the PS5, that's the Xbox Series X, which kind of maximum can really hit like 13 and a half gigabytes. That's on, I believe, the Xbox Series X, or maybe it was the PS5 under some circumstances, but generally keep it under 12 gigs of video RAM. That's the limitation. Well, what happens when we get the PS6 in 2026 or early 2027, and that has a lot more RAM, and that's complete system RAM, so a lot more RAM available for the video buffer in there. What happens to a GPU like this? Suddenly, that can run games with much higher VRAM allocations that are going to look better. What's going to happen with it? That's a big question. Big question. Right now, this is already not enough for ray tracing and upscaling. Upscaling does use VRAM, so it's an open question. That being said, how widespread is this issue? Right now, it's very narrowly focused to games like Indiana Jones that use ray tracing and those high settings and that also eat up a lot of VRAM. Those games are relatively few and far between, and one way to deal with that is you turn off ray tracing. Of course, you could say, well, that's why I bought an NVIDIA GPU in the first place, is because I want better ray tracing. Yeah, the problem with NVIDIA is they want to give you these great features, but then they don't want to give you the actual hardware that you need to run it, like VRAM. Like, how much would it really have cost them to use the 3 gigabyte Samsung VRAM modules, and this would have 18 gigs of VRAM instead of 12, because that's something you can do on GDDR7. Why go to GDDR7 if you can't leverage that? And you said, well, maybe they weren't available cheap enough. Well, can't NVIDIA, for once, just eat into their massive profit margins just a little bit to give gamers the capability that we need? Because at $549, or heck, even $600, go $50 up, if this had 18 gigs of VRAM on it, I would say this is a clear winner over the 9070, right? Which has 16 gigs of VRAM at the same price at $599. But I can't say that because NVIDIA kind of stiffed us. So that is a challenge. I'm not quite ready to revise it up because, again, it's very narrow, but I do think it's on the horizon. It's something that people should be aware of. All right, Scott wants to know, when planning a theoretical build around new hardware like the 9070 XT GPU, how do I determine what CPU GPU combo won't bottleneck the GPU? What tools and online resources do I use to do this, or could you use to do this? Good news. We just released our best CPU GPU combo video, but it just came out literally. I will leave it linked down in the video description. Check that out. We go through builds at every budget level. We give, here's the CPUs that I would look at for this budget level. Here's the GPUs that I would consider the minimum and the maximum GPUs. Anything more than that, I would recommend going up CPU. Anything lower than that, I recommend downsizing the CPU to get a bigger GPU. And again, we have to generalize, because if all you do is play CS2 and you play it at 720p and turn it up to a bajillion, no details, and so you're getting like 1,000 FPS, then maybe I'm undervaluing the CPU for that person. But I try and take a more balanced approach, someone who wants to play a little bit of the competitive stuff, a little bit of the first-person single-player games out there that are more graphic-intensive out there, Cyberpunk, Black Myth Wukong, and we balance that against the Marvel Rivals and the CS2 and the Valorant and all that kind of stuff. And I typically look at data for 1440p that's been tested out there. So that's what I'm roughly looking at when I do these. In the current generation, what I'm finding is that 9070 XT, roughly equivalent to the 7900 XTX, 9070, roughly equivalent to the 7900 XT, 5070 Ti, roughly kind of split the difference between the 4070 Ti Super and the 4080 Super. 5080 slightly faster than the 4080 Super. So it's not that hard to come up with recommendations for CPUs around this. You just have to really do a lot of work and kind of get good at spreadsheets. That's basically it. So I would recommend using the tool that I just developed, and check out our best CPU GPU combo video. Needing Kitty wants to know, should they hold up for a 9070 XT or buy a 9070 and overclock or undervolt? Honestly, I don't mean to make this a trite answer, but I would just grab whatever one you can get. But if you have a choice between a 9070 and a 9070 XT, I'd get the 9070 XT. You can also overclock and undervolt the 9070 XT. I think the market for the 9070, because there was only $50 price difference in terms of the MSRP, and it's like, why does the 9070 even exist then? But what we're seeing right now is 9070 XT prices are going up much faster than 9070. Obviously, much more desirability on the 9070 XT, but the 9070s are still selling out. So if you're budget constrained, you might end up with a 9070, and of course, overclocking and undervolting, that's probably the way to go if you want to increase its performance. See if you can get one with a decent cooler. We have the ASRock Steel Legend here. It's a good model. There's a number of good models out there that are 9070s. We actually broke down every single model for both the 9070 XT and the 9070. I will leave both those videos linked down in the video description. Just go through those videos, kind of understand the models, which ones you're looking for, including whether or not you're going to get the 9070 XT or the 9070. But just know the 9070 XT is going to outperform it because it has more compute units. All right, we got Kindred wants to know, since the RAM price hike, I and I'm sure others can't really justify buying CL30 kits anymore. I think they mean DDR5 6000 CL30, which is what we were recommending for Ryzen as kind of the sweet spot. They're wondering how much worse CL36 kits are than CL30 and what's the new RAM sweet spot. Serene Sunset, basically similar question. What's the disadvantage using CL36 or CL38 versus CL30, specifically with AMD builds? So let's focus on AMD. I would say if you want a full understanding of this, I break down how to understand the speed of all this, including stuff like the speed versus the cache latency in our Best RAM for Gaming 2025 video. Obviously, don't look at the recommendations on that video because we did it when RAM prices were quote unquote normal or under the old RAM pricing scheme, but it will give you a fundamental understanding of how RAM works basically in terms of the speeds. RAM for AMD, you generally wanted to stick to 6000 because that's about as fast as the memory controller on the CPU can run and still be at the same speed as the RAM. If the RAM went faster than that, the CPU memory controller oftentimes can't clock up to it, and so it would go into what's called a 2-to-1 mode. Now, here's the thing. It's a relatively small FPS loss between going from a 1-to-1 to a 2-to-1 on AMD systems, the way the memory architecture works. But on the old RAM pricing scheme, DDR5 6000 CL30 was kind of like the cheapest out there. It was like a $10 savings to get worse RAM. So why? So you always just got the better stuff because there's also future upgradability to think about and things like that. So in testing, what we find though is that CL36 or CL38 RAM versus CL30, very little difference unless you get to an RTX 4090 or a 5090 or relatively high-end GPU operating, especially at lower resolutions. And as you go up in resolution, the RAM speed matters less. So right now I would say the sweet spot is, and we went over this in our best RAM video, maybe we'll just do that every month. Let me know if down in the comments if you want us just to go through the best RAM that we can find every month. I'm finding that anything, I would say 5600 CL40, which would equate to 6000 CL42 or faster RAM is absolutely fine. And it's okay to go over 6000 now, because again, it's a relatively small bump. It might add up to 50 to 70 bucks. And that 50 bucks, you could get more performance going from Ryzen 7600X to a 7700X. So why wouldn't you do that instead of get better RAM? Like, who cares making the 7600X a little faster? Get a 7700X instead, or a 9600X. So you can do the same thing jumping up to the 7800 X3D. If you're almost to the 7800 X3D, why get better RAM? Get the worst RAM and get the 7800 X3D, because those X3D CPUs absolutely do not really care about RAM speed, except again, in these crazy circumstances, like if you have a 5090 and you're playing at 1080p or 1440p, like ultra low settings, then yeah, maybe you'll see a small difference, but I'm talking like a couple FPS difference at most. Here's a really good question. Nyla Creel wants to know, are there any cheap RAM sticks you should avoid buying during the shortage? I have seen like, what is it, like a Pacer or something like that. Just some kits out there that I've never seen before. And it's probably because I didn't have to look this deep before. You know, you could just buy whatever you wanted. V-Color was another one, although I did check in a V-Color. They appear on most of the QVL lists for the RAM out there. So I think that's probably fine. For DDR5, it does feel like it's a smaller pool. For DDR4, I have noticed a lot of off brands out there. I don't know if they're sending them in from off brands in China where they're making the DDR4 or not. But for DDR5, it seems limited to most of the brands that I'm familiar with. Clev is a brand that I've been recommending a lot because their pricing has been much better than everybody else. Some of the brands that I had been recommending quite a bit in the old days when they had the best pricing have been the ones that have massively raised their prices the most. And I'm looking at you, Silicon Power and Team Group. I recommended your kits for a long freaking time. And I feel like you're really screwing us over now, because if I look, who's the most expensive out there? Number one, Team Group, but number two, Silicon Power. Give me a freaking break. Gamers got long memory, so just I'm watching you. But I would just say, generally, most of the RAM out there is probably fine. Once you get it, I would test it as soon as you can, though. Put it in your build, because I think that you want to make sure that if it needs to get exchanged, because you will get bad kits. I've gotten bad kits from everybody once in a while. And yeah, we put it in, you try and clock it, you adjust the voltage and stuff. Can't really fix it. I'm like, okay, well, the kit, clearly one stick. Usually one stick is just not great on it. Usually I'm like, okay, send it back, and they exchange it, and then next kit comes and it works fine. So I would just say, once you get your RAM kit, use it immediately. Make sure it's okay. Run like Memtest 64, like really hammer it. Make sure it's okay. And then, you know, if it's not, exchange it right away. Great question for anybody thinking about either upgrading their GPU or buying a new PC, basically, or building a new PC. RayCF, anything to look out for compatibility and performance when upgrading your GPU. For example, PCIe Gen 5 GPU connector with a PCIe Gen 4 slot on the motherboard. Memory is DDR5, while GPU is DDR6 internally. Here's the thing. I know this can get really confusing for folks. So the VRAM that's on the physical GPU, and I got one right here, the VRAM is actually on this card. You don't need to worry about whether that's GDR6, GDR7, any of that. And you don't need to worry about the RAM that you have. Those are two different systems. The GPU has its own VRAM you don't really need to worry about. The system RAM is the part that you need to get right. In terms of upgradability, there's a couple of key things. First of all, the PCIe slot here, this is backwards compatible. So you don't need PCIe Gen 5 motherboard in order to use a PCIe Gen 5 GPU, like for instance, the RTX 5080 here that I've got just off camera because we just did our best CPU, GPU, and we haven't cleaned up from the combo video just yet. And yes, I did buy this, by the way, for massively overpriced sum because nobody sampled us. But if you have a GPU like this, even though it's Gen 5 GPU slot, and I have a motherboard with a Gen 4 slot, don't worry about it. It's backwards compatible. It'll just run at the slower rated speed, which is Gen 4. And guess what? An RTX 5090 works just fine on PCIe Gen 4. So the things that I would think about when actually upgrading my GPU is, number one, do I have enough power to run this GPU in my existing system or am I going to need to upgrade my power supply? Now there's two things. One's the total wattage, and you can check out our best PSU video. You can check that out in terms of how to estimate your overall system consumption in there, put in all your components. And then of course, there's also, does your power supply have enough physical connectors? This is a single 8-pin on this one. Some have two 8-pin. You'll often see it 2, 6, but plus 2 pins. That's actually two 8-pins, same thing. But you have enough physical connections for it. And then of course, the other thing is in your case, like this is a very simple RTX 3060 12 gigabyte GPU. It's a very small card. If I pull out some of these other cards, they're just super beefy honking things. Do I have enough clearance, both horizontal clearance or length of the card wise, and then in terms of how many slots wide it is? Some of those cards are very, very wide, and they could actually bump into the bottom of the case. So those are the things that I would think about when upgrading my GPU. Is it going to fit in my case? Do I have enough power for the card? And do I have enough PCIe GPU connectors in order to make this work? Or am I going to need to upgrade my power supply? Now, of course, the other thing that I think about is my CPU going to be powerful enough to leverage this graphics card, or is it time to think either upgrading the CPU itself or just doing a new build because I'm at the end of the upgrade cycle for the CPU on that platform? Especially if you're on like an older Intel 9th, 10th generation. If you're gonna buy like a 9070 XT or something like that, or a higher end GPU, it's generally a good idea to go ahead and just build a new system. All right, Mormon Dude asks, do you think we're ever gonna get serious performance gains between generations, GPU generations again? Or do you think we're starting to approach the atomic limit for transistor size that make it so that all the performance that there is to be gained, we've already gained it? So what Mormon Dude is talking about basically is something that my friend and I, my friend who works for a major semiconductor manufacturer, if you heard the name, you would definitely know it, have been talking about for decades at this point, which is like, have we reached a point where the processes have gotten so small that we're basically exceeding the limits of the type of computing that we know? Obviously, there's quantum computing, there's other things going on right now, but that's kind of more science fiction than science fact right now. It's in the laboratory. It's not something that you can purchase right now. And that's one of the big questions. So this is an RTX 5070 here. This is the MSI Shadow model that I purchased at the launch of the 5070. We purchased most of the GPUs that we use on this channel, just FYI. We do get some sent to us from time to time. For graphics cards, we largely purchase all of these. That's why these kind of discussions are important to me, as they are important to you. Like, if you look at the performance of this 5070, it basically performs like the 4070 Super. And if you look at the 50 series in general, except for the 5090, basically these perform very similarly to the last generation RTX 40 series cards. That's why in reviews, you heard them called 4070 Super Duper, basically, because it only ekes out a little bit more performance. People are like, well, Jason, I don't understand. It's the next generation. Why isn't there more performance for the 50 series? Well, you can get performance in a couple different places. Let's quickly go over this. The number one place you're always going to get the most performance historically is to take a process like this, right? A card like this, say this is the 40 series card, and to shrink the process node. That means basically you're miniaturizing the number of transistors that can fit in the same die space. So you're going to get more transistors in the die space because the transistors are closer together. You're going to get more performance per watt. It takes less energy because you're getting more performance per watt. You're getting less heat dissipation out of it, so it requires less cooling for the amount of performance. That's always the lion's share of the performance gains. And if you look at 40 series over 30 series, you saw that in the 40 series, especially with the 4090. We saw just generationally huge jump for the 4090, but this generation, we didn't see it as much. The other place that we could see jumps in terms of performance is the VRAM, for instance, going to faster VRAM, or basically being able to process more in the VRAM process. So one thing we could do, we could go to a wider bus size. It didn't get wider. In this case, it's basically the same as the 4070, but in this case, the VRAM got faster. They went to GDDR7. But that has more limited applications because largely games are not VRAM speed limited. They can be VRAM total buffer limited, right? Well, 8 gigabytes, we're running into that. But in terms of the speed of transitioning stuff between the GPU and the VRAM itself, we're not really there. We only get a small amount of performance out of that. And then, of course, we can also get performance in terms of architectural revisions. So for instance, if you look at the Arc B580, which I actually also have sitting here, a lot of the architectural revisions they made and how it processes images over the Arc A series cards allowed them to get a lot more performance of this card, to run games a lot better without having super optimized drivers with it. So that's one way you can do it. The other way you can do it, if you don't completely redesign the architecture, as they did here, is you can just make architectural improvements. So think about, people made fun of Zen 5%, right, for Ryzen 9000, because Ryzen 9000 isn't that different than Ryzen 7000. It's just small architectural improvements, except for like the 9800 X3D, where they did have a new type of process. They put the X3D cache instead of on top of the CPU, they put it underneath the CPU, allowed a lot better thermal contact, so they were able to run the CPU a lot faster. So that's one architectural improvement. So those are the places that you can get uplifts on a GPU like this generation over generation. So what the heck happened to the 50 series? Well, basically, NVIDIA is not a gaming GPU company anymore. They're the ones who would tell you that, not just me. They're like, we're an AI company now. We're not a GPU company any longer. So they needed a way to basically take the allocation of silicon that they get at TSMC, which is the major manufacturer and the most advanced node manufacturer of silicon in the world. Primarily those processes are in Taiwan, in China. They needed to take the amount of silicon they get and basically ensure that they can make the most AI GPUs possible, because that's where they make their money, because nobody can compete with them in terms of their AI GPUs just yet. So they made a decision to take their entire Blackwell architecture, including the gaming GPUs, and they capped it on the older process, which is called the 4N process. It's called 4N not because it's 4 nanometers, but because it's the fourth process, and the N stands for NVIDIA custom process. So that's a TSMC kind of insider baseball thing. So basically they stayed on the same process. That's why when they announced that in the fall, I was telling people, I don't know if you want to wait for 50 series, because I'm not convinced that the uplift is going to be that much. So that's largely what the problem with the 50 series GPUs has been. Hopefully next generation, they will use a smaller node. But again, they're facing, when you use a more advanced node, only so much can be produced. That's why they stayed on the older node, because they can produce a lot more at TSMC, and they can sell a lot more, and they can make bajillions of dollars, which is what companies are really designed to do. Cole Mestovich, what do I personally do to reduce static electricity? Almost nothing. I remember back in the day wearing static wristbands to reduce, yeah, we did this, to reduce chance of frying any components. Is the hardware these days better at resisting static? Now, no. We just worry about it less. Most people build it without anything on. So static electricity was probably massively overblown in terms of the ability to damage an actual component. I'm not saying it's never happened. Of course it's happened. It's just happened at a far lower frequency than we all used to freak out about. I would say if you're building a PC or you're handling PC components, let's handle some PC components right here. There's some obviously fine places to touch most of this. For instance, this back plate, this is just a big hunk of metal. It's actually not touching with the card. In fact, it would be nice if there were some thermal pads connecting it to the back for heat reasons. All that being said, this is not a really high heat GPU, probably doesn't need it. But for instance, if I had a motherboard or a CPU, don't rub your hands over the back of the CPU where the pads are. Just do common sense things. Don't wear socks on carpet. We have carpet in this room for sound deadening reasons, right? Because it's a recording studio. So I just never wear socks on this. I either wear my actual shoes, or most of the time I just wear bare feet, basically. That's all you really need to do. Don't take and rub your cat all over the PC parts like this. That will probably also not be good for it. But that being said, these things have turned out in the long run to be far more resilient than I think we used to freak out about. So I wouldn't really do anything special. All right, we got Mormon Dude asking, do I feel like ray tracing's justified its existence, or do you still think it's more of a gimmick in terms of being a feature in games? Blue Shadow, essentially same question. What are my thoughts on ray tracing and path tracing? Do I think these things should be in video games? Well, it's not so much a matter of whether or not it should be in a video game. It's a matter of whether or not it should be forced into video games, because that is my problem with ray tracing and path tracing. And it's not just that it's been forced into video games, it's been forced into GPUs, it's been forced into GPU reviews, it's been forced everywhere because it has been essentially weaponized. It's not just a technology. I'm not anti-technology. I'm against technology being weaponized to pursue the control of the media, of gamers, of game developers, because that's what NVIDIA has essentially done with ray tracing here. Let me back up and explain. Ray tracing has been around since 2018. That's when it was first introduced. 2018. We're in the 7th year of ray tracing. Pretty soon, in a couple months, we will be in the 8th year of ray tracing. Crazy to think about. Hardware Unboxed last year did a whole survey on all the ray tracing games out there, at least a large amount of them, trying to determine which games had absolutely been really transformative. It's a relative handful. Think of the thousands of games, thousands and thousands of games that have come out in the last 8 years, and you come out with a handful of games that are ray tracing. Now, on the one hand, if ray tracing wasn't now required in a lot of games like Indiana Jones or even Doom, the new Doom game that just came out, that would be one thing. If it was just this optional toggle switch, I wouldn't care. And this is my same problem I have with multi-frame generation and NVIDIA trying to cram that down our throats next. What NVIDIA has done with it is they have weaponized this to control all those elements. Let's start off, for instance, let's just talk about game reviewers or tech reviewers. And this is not, I think, a fault of tech reviewers. I don't want to throw them under the bus. This is 100% NVIDIA's fault, and it's the culture of fear and compliance that they create with their marketing and with all this kind of stuff. Because to them, it's not just some cool technology that can enhance the lives of gamers and other people. To them, it's a proprietary technology, essentially, that they can use to hone their advantage and make more money for themselves and shut out competition and basically create their own powerful empire. So let's talk about tech reviewers. Let's start off with the Arc B580. Like, Jason, that's a $250 GPU. What does that have to do with ray tracing? Of course, a $250 GPU isn't going to be very good at ray tracing. It takes, $800 GPUs to be good at ray tracing. Yes. So when the Arc B580 came out, all the reviewers did what? What did they test? Did they test the fact that it had only 8 lanes of PCIe Gen 5? So on older systems, it would be hampered by the limited PCIe bandwidth? No. Did they test the fact that on older CPUs, it might be hampered because of CPU overhead? An issue that I admit I didn't think of either at the time. I was more focused on the PCIe Gen 3 versus 4 versus 5 with only 8 lanes on it. But did every single reviewer test the ray tracing capabilities of a $250 graphics card? Now think about this for a second. And I don't blame the reviewers, because if they had not, imagine you're a reviewer who had left out ray tracing from a $250 GPU. First of all, you'd have all the NVIDIA fanboys, attacking you in the comments saying, oh, no ray tracing, this guy, you would have gotten blasted. So of course you're going to do it, because there's a culture created around this. It's expected. And if you're a person who actually wants to buy a $250 graphics card, what are you most worried about? Are you worried about its ray tracing performance? Of course not. You're worried about, hey, is this going to work on my Ryzen 3600, on my, i7 9700K or something like that? That's what you're worried about. Is it going to work on my older hardware? Because you're probably a budget gamer. Or if you are going to build a new system, hey, what CPU do I need to pair with this in order to get the best performance out of it? You would have answered none of those questions in almost any review. I did see Wendell from Level 1 Tech. He did briefly put it on like a 10700K, but he didn't do any charts or anything with it. And again, this is not the fault of reviewers. The reviewers have limited amounts of time to produce these reviews. They've got to check all their boxes, and ray tracing has become a required element of GPU testing. But at the same time, how many games absolutely have transformative ray tracing out there, and how many people with a $250 GPU are expecting to have high-end ray tracing at zero, like nothing? So you can see where those things are just not matching up anymore. And it has to do with the kind of culture that NVIDIA has brought around ray tracing. They've tried to use it to their competitive advantage. Oh yeah, AMD beats us in rasterization, but what about ray tracing? It's like, oh my God. If you don't have ray tracing, they're basically continuously preying on the fear of missing out, FOMO, from gamers. Oh, but what about ray tracing? Ray tracing is the future. Ray tracing has been the future for 8 years and it ain't here yet. So what does that mean? Because the hardware just can't keep up with it. Even the hardware is getting faster, even though it's not getting faster fast enough. We want to go from 1440p to 4K. Well, that's going to massively increase the ray tracing workloads as well as you go up. It's going to massively increase VRAM workloads. NVIDIA also doesn't want to give you enough VRAM to ray trace, even though it's one of their own features. And of course, then it's been forced into games. It's been forced into games everywhere, and it's shutting out people with older hardware from fully enjoying a lot of these games, or they have to enjoy it in like a console-like experience. Then you have a game come out like Kingdom Come Deliverance 2, And it's like, hey, this game doesn't have ray tracing, the graphics still look really good, and it runs great on older hardware, and it's a lot of fun. It's a lot of fun. So it's basically been forced into a lot of games because now game developers feel like, well, if we don't have ray tracing, we need that element in order to attract more of an audience. So at the end of the day, number one, I think the technology has absolutely failed. Limited amounts of game, it requires massively expensive hardware, and that hardware that you're paying $800 for right now, probably in a couple years will not be able to do high-end ray tracing on the latest title that's just come out because it'll be too old. Like right now, what's the ray tracing on an RTX 3080 10 gigabyte? What is that that was a very expensive GPU in ray tracing. You can't get the 6800 XT, you have to have ray tracing. Really? It's got 10 gigs of VRAM. How much ray tracing is that GPU doing right now? The 5070, how much ray tracing is that gonna be doing? A $600 graphics card right now. In a couple years time, with only 12 gigs of VRAM. Play it on Indiana Jones and the Great Circle, 1440p Ultra, even with upscaling on it, it just runs out of VRAM with the high ray tracing settings. So I think ray tracing is just another example, and I think multi-frame generation, they're trying to use the same cudgel of multi-frame generation the same way they did with ray tracing to always say, you're gonna miss out if you buy the competition's product. And then they're gonna basically force reviewers to review this stuff, even though it's not pertinent to a lot of GPUs out there, like, more budget focused. Hell, most GPUs under $800 is really not that relevant. So then you're just talking about this niche up here, but they're having to apply that all the way across. And it's basically just a way that NVIDIA continues to control everything. So I have no problem with ray tracing as a technology. I have no problem with trying to introduce it in games, but it has to be able to be toggled off. And I think what we've seen is that we've got to step away from the weaponization of these technologies in order to prop up a proprietary monopoly of one particular company out there. NVIDIA's not the only one who does this, by the way. Apple, but I will say NVIDIA is probably the most successful in the PC space for doing this. And I'm not saying that AMD or Intel or anybody else wouldn't do it if they could. We've seen in the past that these companies tend to pursue these kinds of, proprietary tent poles that they can fend everybody else off of in order to solidify their advantage of something. So all in all, I think that currently ray tracing is being used as a weapon, and it's hurt gamers, it's hurt game development, it's hurt reviewers, it's hurt the tech media out there, it's created a climate out there that is, I think, just negative for the overall PC gaming space. The good news is I think at this point, people are kind of over ray tracing. I think they're getting over ray tracing, and then we're kind of starting to move on. And I'm hopeful that multi-frame generation will not become the same kind of cudgel that ray tracing has been. Do I think the addition of frame gen gives games like Borderlands 4, oh my gosh, what a disaster, an excuse not to optimize? Yeah, let's talk about that. The 9800 X3D 5090 should do much better than 50-ish frames at 4K. And I want to let's jump into some numbers here. I have seen people compare this basically to Cyberpunk 2077, and I don't think that's a fair comparison. I'm aware that Cyberpunk 2077 is now in Unreal Engine 5. However, they didn't start there. I want to compare it to a brand new game that was developed in UE5 from the get-go and launched in UE5. Let's start off and let's of course take a look at the numbers for Borderlands. Right now it's sitting at a mixed review, which is not good, by the way. It's not terrible. 22,397, and I think it's like 60, it says 65% positive, basically. We've seen games come out that are either negative or overwhelmingly negative. So I think obviously the game is good enough, even with the crazy, crazy low FPS that we seem to be getting out of it, for most hardware settings, even like a 5090, to basically warrant people are still having some fun. We've unfortunately become used to bugs in games at launch. I mean, look, there's been bugs in games forever. I get it. You can only squash so many bugs. You can only do so much internal QA testing. Then you send it out to everybody, and there's stuff that you could never have fixed. I get that. And if you get that cleaned up, I'm fine with that. I'm absolutely fine with that. I think what we're not fine with is the terribly low FPS targets. Because if you look, I mean, here's the graph. If you look at the reviews of it, just spend some time reading these Steam reviews. They're all basically like, this is terrible. This is not what I've come to expect from a Borderlands game or this style of game. which is a first/third person shooter. It's a little bit faster paced game. And of course, we got the game dev from Gearbox, Randy Pitchford, basically telling us, oh, this is not an FPS. It kind of is. And I think that's the expectation. So when you're developing your internal targets, maybe you should think about that. Rather than lecturing us about what the game isn't, maybe you should listen to us about what this is your audience telling you what they want. Listen, I don't know why that's so hard for people these days. But let's compare this to a game that came out not too long ago, actually launched in Unreal Engine 5, and let's look at the difference. And that is Clair Obscur Expedition 33. I never say the name of this one right for some reason. And look at this, 97% overwhelmingly positive, 63,000 reviews. That's insane. And this is a really nice graphics game. I'm aware that they're slightly different kinds of games. This is largely kind of turn-based, but there are some real-time aspects of it. And the graphics look amazing on it. They absolutely look amazing on it. But let's take a look at the FPS number difference here. Let's start with Borderlands 4, and this is Tech Power Up, and we're going to compare their benchmarks side by side, basically. So Borderlands 4 with an RTX 5090 at 1440p on the highest settings, which is badass. 62 average FPS. Yikes. So what if you have a 5070? 27 average FPS at 1440p. We'll get into the upscaling in a second, because they're not just telling you to use upscaling, by the way. They are telling you to use frame generation, and that's kind of where I draw the line. What about Clair Obscur 33? With a 5090, they got 95 average FPS. Wait a second. 62? Click back. 95? That is a 50% increase of FPS. Similar engines, they're using Lumen, they're using Nanite in this game. Now, I'm not an expert in any of these engines. I'm sure some of you game developers out there are like, Jason, well, there's technically, that's fine. That's stuff that the company needs to decide internally when it's deciding on targets, because their target for a lot of hardware is basically 30 FPS, a console-like gameplay. And I think what people are saying is that's not good enough. And then for the higher end recommended hardware, it's 60 FPS. And again, people are saying, like medium settings, that's not high enough. So maybe they should start listening to that, because again, it is possible. Look at this game. It's possible to get that FPS, 50% more FPS. Let's look at upscaling. They kind of did different things with upscaling. Let's look at what an RTX 5070 Ti at 1440p using quality upscaling. This is Borderlands 4 here, right? Borderlands 4 upscaling performance at 1440p. 72 average FPS using the quality settings. Clair Obscur, they just used quality settings basically. And if we look at the 5070 Ti, where'd it go? 95 average FPS. So yeah, not quite 50% more. So DLSS upscaling is helping out quite a bit there. But here, getting back to the question, right? Are they basically going to use frame gen as an excuse not to optimize the game? I think we've just shown that probably there is more FPS to get. And honestly, I guarantee you, just like Borderlands 3, we will see performance patches come. In fact, he's promising in this thread, Randy Pitchford, the studio head, the CEO of Gearbox, he's promising that they're working on PC optimizations. My question to him, rather than lecturing us about DLSS, and by the way, when he says DLSS, I don't think he's just talking about upscaling. He is talking about frame gen. And this is part of NVIDIA's push to brand frame gen, instead of calling it frame generation, to brand it as DLSS, because people look at DLSS upscaling as a good thing, and it largely is amazing. But now they want to basically take this really ugly thing and smash it in there. So, oh, it's all DLSS. We're just talking about DLSS. No, we're not buying that. And that's, I think, what people are having a hard time with on a tweet like this. Use DLSS, it's great. Yes, I think he's not just talking about the upscaler again. He's talking about frame generation. Game was built to take advantage of it. Clair Obscur, by the way, was not built with frame gen built in. Borderlands 4 was. I've been led to believe that in a blind test that humans cannot detect any input lag. Humans cannot detect any input lag. Hey, did you know that, by the way, no matter how laggy your setup gets, you can't detect it? Come on, like, you don't have to gaslight us. Tell us, hey, we know it's not a perfect solution, but it should improve your gameplay. Like, say something that's not just randomly insulting. Please say something that's not randomly insulting. I don't have a problem if you want to make an argument for using the technology, but it does seem like, yeah, they are going to try and use this. And honestly, what can we really do? Well, I'll tell you, we can complain about it, and we can basically let everybody know that if this is what you're going to pull, you're gonna get raked over the coals. On Steam, the Steam reviews are gonna look terrible. It's gonna hurt your sales until you start listening to us. And honestly, that's the only things will ever change. Unfortunately, with NVIDIA, because they've gone so into the AI universe and that's where all their money comes from, we have very little, almost no voice as gamers into that. But you know who still has to listen to us? Game developers. Game developers still have to listen to us. So yeah, keep using your voice out there. Wirehead channel member, by the way, you too can join. Click the join button after you subscribe down there. We do live builds, live boost my build, live Q&A, all kinds of fun stuff. Ask, do you find that different network connectivity on most current systems is adequate at 2.5 gigabits for gaming, or is 10 gigabits per second going to become the needed connection speed anytime soon? High-speed internet becoming more ubiquitous. Are you finding connection speeds being almost as relevant as frame rates, or maybe more so in some cases? Does it give players a tangible advantage? The games these days don't require that level of bandwidth. It's kind of crazy because I still remember dial-up and like 300 baud modems and then 1200 baud modems, 3600 baud modems, you know, like you're talking about bits and then kilobits now. And then we went to megabits per second. Now we're talking about gigabits per second. We're talking tons of data. The good news is a lot of the games don't require this level of bandwidth, but a lot of people want to do a lot of other things. And oftentimes on your network, even if you have your gaming PC here, maybe someone's watching on a smart TV that's sucking up bandwidth, other things are going on. So it's really about how much bandwidth you have on that individual PC. I will say switching over from wireless to a wired connection will often lower your latency by 20 milliseconds. And that can make a really big difference, but that has nothing to do with bandwidth as much as it does with the latency, right? That's the time between the information coming in. That's just the difference between even like Wi-Fi 7, which is better than Wi-Fi 6 and Wi-Fi 5, and a wired Ethernet cable, which is just boom, instant. So I'd say the first thing I would do is switch over to wired Ethernet. Most internet home connections still are not more than a gigabit, if you think about it that way. And most Ethernet connections on the back of your motherboard typically come between 1 gigabit per second and 2.5 gigabits per second. So for most people, 1 gigabit is more than you need. And honestly, just to play a game, it's more than you need. So I wouldn't really worry about that. I'd worry more about like optimizing your local network, making sure that there aren't a lot of devices on it, making sure that your router's running up to snuff on it, and that you're having a wired connection if you absolutely can. If you're playing like, single player titles and it just has to be connected to the internet or something like that, usually no big deal. This is mostly for like competitive multiplayer games, Rocket League and CS2, stuff like that. Depending on what you're playing out there, World of Tanks, any game where latency is going to make a big difference between you kind of winning and losing the duel, yeah, that's going to make a difference. I would say go to a wired connection first, but really not yet any big difference between 1 gigabit, 2.5 gigabits, and certainly not 10 gigabits. All right, let's do the speed round. David, how much overclocking do I need on my RGB to run at max FPS on Minecraft? Well, you have to know, David, that RGB equals FPS. It's just absolutely science. It's just science. More RGB equals more FPS. This right here, this is good, but I could do better and get more FPS if I had more RGB going. All right, Master Obi-Wan wants to know, love your channel, all your content. However, which one of your cats is the real star of the show? Is it Mr. Bear? Well, Mr. Bear, in case you can't see, is sitting actually right here. He's gonna get very mad at me as I move. So he actually sits here all the time, and this is his spot. He's going to claw me if I'm not careful. This is his spot. He absolutely loves being here. On days when we're even not filming, he comes in here and he goes to work, basically. He goes to work every day. He's a very good kitty. Yes, say hello to your adoring fans. He's facing the wrong direction. He's clearly the star of the show. I think Waffles has recently become more the star of the show. He likes to get up here when we're filming and kind of get in front of things. And then Lisa, she likes to just jump on top of PC cases. So anytime we do a build, which often we do for like, member live streams, she tends to want to jump on top of the build and get some airtime there. So, but I would say Mr. Bear is the OG here. And yes, he's the star of the show more than I am. 3D Chick asks my question: how did Ambroisus become Mr. Bear? Mr. Bear morphed from Ambroisus in a really funny way. So it was, I think we got him about 10 years ago, and he was pretty young. We had a friend, he needed to move to a new place and he couldn't take the cat with him. He's like, I don't know what to do with this cat. Either I just need somebody to take it or I have to take it to a shelter. So we said, hey, okay, give it to us. Let's see if this works out. And sure enough, we fell in love with Mr. Bear. Absolutely fell in love with him. He fell in love with us. And I don't remember what his name was before that. I've kind of just scrubbed it out of my brain, basically, because to me, he's always Ambroius or Mr. Bear. We named him that because Sarah loves this movie called Labyrinth. Labyrinth is a movie, it's like an 80s movie with like Jen Henson puppets and stuff, and it's goblins, and David Bowie's in it. I grew up with him. Great movie. Sarah loved it. And there's this knight, I think he's like a rat knight, and he rides a dog named Ambroius. So we love that character. We named him Ambroius after that. But Ambroius, while it does kind of fit him, he's such a big cat. He is such a big cat. People don't realize how big he is for a cat. We call him the House Panther, but we called him Mr. Bear because he looked like a bear cub, basically. He looked like a baby bear cub. He was that big, and the name just stuck, so we just call him Mr. Bear all the time. Now, he will come to either Mr. Bear or to Ambroius. He knows both of his names. He's actually a very, very smart cat. We're pretty sure he's a melanistic Bengal. So he should have stripes, but because he's melanistic, you can't really see them. But the thing about Bengal cats is that they're super, super smart. He's a little too smart for his own good sometimes too, let me tell you. We absolutely love him. We love the name Mr. Bear, and we call him Mr. Bear and Ambroius interchangeably. If you got value out of this video, please give it a like. It makes a huge difference to the channel. And of course, subscribe for more cool PC content, and we'll catch you on the next one.